بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. Let's talk about something called phase difference. Okay, phase difference. In order to understand phase, look to these particles. Now here we have three sets of particles that are oscillating. Look to the first one, the first set. Okay, this one. Guys, are they oscillate in phase? Are they oscillate together? Yes, it's clear, guys. It's clear that these two particles are oscillating in the same way. يعني both of them will move up together, both of them will move down together. This is called N phase, right? This is called what? N phase. Okay? Any question? I will explain later what is meant by phase, but now we can say that they are in phase. Look to the second set. Wait a moment. Look to this. Guys, they are oscillating totally opposite, right? Look, when the first particle is moving up, the second particle is moving down. Guys, look to the words that I will use here, or listen or pay attention to the words that I will use here. Guys, look, when the first particle is moving up, the second particle is moving down, right? Did you see that? These are called antiphase, guys. These are called what? Antiphase. They are totally opposite. Okay? Last one, or last set, they neither in phase nor antiphase. يعني هم لا هم in phase ولا هم antiphase. هذا مسميه out of phase. And sometimes at certain moments they are moving together up, down. At certain moment they are moving opposite to each other. فهذا مسميه احنا out of phase. هذا مسميه out of phase. Is that clear? Okay. Now, how can we represent that? How can we represent the phase? How can we represent what? The phase. Look. If I ask you a question here, if I take snapshot, let me go back. Okay, guys, look to this particle. Look to this particle. Are they in phase? Guys, higher particle, they oscillate in phase. يعني both of them will move downward together and move upward together. مع بعض. شايفينهم؟ طيب. Is that clear? If there's any question, please ask me. So they are in phase. Why they are in phase? They are oscillating at the same moment. يعني they will have the same displacement at the same moment, right? Either upward or downward. Now look to my question. What about this one, this particle, with this particle? Are they in phase? يعني here main point, guys, I can understand that if I consider the direction of oscillation or the direction of movement. When this particle is moving up, the other particle is moving down and vice versa. عشان هيك هدول بنسميهم احنا anti phase. هدول ايش بنسميهم؟ anti phase. Okay. هلا how can we represent mathematically الphase؟ هلا احنا تقريبا we understood the concept of the phase انه in any disturbance in any wave there are particles that oscillate together, or in other words we can use they are oscillating in phase. There are particles that are oscillating anti-phase. There are particles that oscillate out of phase. If I consider this particle بهذا البوزيشن شايفينها مع هاي البارتيكل the next one هدول بنسميهم out of phase. These are called what? Out of phase. At certain moment or between two moments they are oscillating in the same direction. At certain or between two moments, two other moments, they are oscillating in the opposite direction. واحد يعني يا اثنيناتهم بيكونوا عم يتحركوا ب certain moments up او ايش at certain moments they are moving opposite to each other, واحد up وواحد down. هذا بسميه out of phase. هلا we need a mathematical representation for that.
طيب بس سؤال الاوت اوف فيز هدول ممكن نحكي كمان عندهم راندوم موفمنت انه
بالضبط random
معنى ثاني؟
movement. Yes, random movement. يعني احنا عندنا two main cases. الان phase انهم they are oscillate together. الانتي phase they are oscillate opposite to each other. وfinally out of phase any other thing. اوكي طيب stop نوقفه. اوكي هلا we need a representation for that. Since guys the waves repeat أو wave in general it repeats itself periodically, فthey use angle. Mathematically they use angle to show what? The phase. Why? Because guys إنه circle, if I have a circle like this, if I have, let's say, a particle that oscillates, that is move along a circle in this way. This is, let's say, this is 0 degree. This is 90 degree, right? This is what? 180. Just a moment, Tariq. This is 270. This is what? 360 again. So a wave repeats itself every one cycle. Well, one cycle can be represented as what? 360 degree. يعني كل one cycle mathematically can be represented using an angle, right? Using the angle here 360. But the wave repeats itself 360. يعني this is time. Guys, look to this graph. This is time, this is phase. At one cycle, at one complete cycle, the phase will be 360 or 2 pi. They use the concept of 360 or 2 pi or angles in general in order, guys, to show you the wave repeats itself periodically. Yes, طارق. The main point that I have to consider انه بس الفيز، فكرة الفيز. يعني مثلا if I ask you what is the phase here تقول لي 0. هون مثلا 90. هون 180 الفيز difference. Sorry, phase. Here 270. Here 360 and so on. Okay, and what? So on. 0. هون 90, 180, 270, 360. Right? If there's any question, please ask me, guys. Okay. Now we need to find what? The phase difference. Phase difference between 2 points. Phase difference between 2 waves. No matter. يعني احيانا بيطلب مني مثلا نطلع الفيز ديفرنس ل 2 points واحيانا بيطلب مني we have to find a phase difference between 2 waves. I will show you that. If you are asked to find the phase difference between 2 points, I have to take per consideration which graph we are given. Displacement time or displacement what? Distance. If we are given displacement time like this, I have to find the shift in the time between the 2 points. I will show you how. I have to find what the shift of the time like this. This is t. T is called what? Shift in time. This shift in time divided by the period multiplied by 2 pi, I can find the phase difference. Or instead, if I want it in degree, I can multiply it by 360. If you are given displacement distance graph, I have to find the position shift, x. In this case, I have to divide the position shift over lambda times 2 pi or 360 if I want to find it in degree. Let me show you something. I will show you that later on. And let's go back again to the phase difference or in phase. When can I say that the particles are in phase or oscillating in phase? When the phase difference between these particles are what? 360. 360 or 2 pi or what? 2 pi or any integer or even integer of pi. Any even integer of pi. يعني 2 باي 4 باي 6 باي هدول كل البارتكلز راح يكونوا in phase او 360 720 and so on. الانتي فيز اذا كان الفيز ديفرنس بيناتهم 180 or 540 or 900 الجنرال رول n times 180 where n should be odd or pi 3 pi 5 pi where be odd, otherwise ايش بيكون out of phase. let me explain that for you. So we need also a mathematical representation for this phase. So they use angles 360 degree because the wave repeats itself every 360 degree. They consider this is as 0, this is 90, this is 180, this is 270, 360, again, and so on. This is, if we add 90, it becomes 450, right? Here, 540. Here add 90, 630. Here, and so on. We took that before, but just to remind you, if I represent the phase using an angle, because the wave repeats itself every 360 degree, right? Like the circle. Circle repeats itself every 360 degree. So the phase difference between this point and this point is 360. So they are in phase. Between this point and this point is 180. So they are anti-phase. Otherwise, any other case, it will be out of phase. Okay? Guys, the first set, these two particles in the wave are oscillate in phase. The second two set of particles, right, are oscillating anti-phase because they are totally moving in the opposite direction. And if one particle is moving up, the other particle is moving down. The third one, it's called what? Out of phase. Well, I showed you this also the previous time. قلنا guys, three particles are oscillating in phase, particles are oscillating anti-phase, particles are oscillating out of phase. Quick things here. This is a wave. We want to describe the position of the particle. We may use a concept of angle. Since guys, in the weight like angle repeats itself every 360 degree. So if I consider this as a 0, this will be 90 degree. This will be 180. Here 270. Here 360. 450. 540, 630, and so on, guys. If you take the phase difference between this point and this point, which is 540 minus 180, I will get 360. So they are oscillating in phase. They are oscillating in phase. And this particle and this particle are oscillating in phase. This particle and this particle are oscillating in phase too. Okay. If I subtract or if I find the position or the phase difference between this and this, 450 minus 90 equals also 360. So this means that these particles are oscillating what? In phase. This particle are oscillating in phase. Okay, guys. Um, so
أستاذ مش نقدر نستخدمها بالراد سيستم نشتغل بالراد
طبعا
سيستم.
definitely we can use the rad system.
أوكي.
بس المين بوينت تاعتي هون انه نشوف انه شو يعني in phase وانتي phase. يعني if you consider this particle مع هاي البارتيكل مثلا هاي مع هاي هدول انتي phase. ليه؟ لانه الفيز difference بيناتهم 180. Look guys, if you consider this particle هاي مثلا this particle again مع البارتيكل اللي هون برضه هدول انتي phase. هدول برضه ايش؟ انتي phase. يعني هاي 720 yes 720. If I find the phase difference, let's say this is A, this is B. If I find the phase difference بيكون 720 minus what? 180. 540. Okay. If you divide 540 by 180, I will get 3. If I got odd number معناته هذا anti phase. If I got odd number معناته هذا ايش بيكون anti phase. Okay. Let me show you this. Okay, guys, look here, please. Let me consider this this wave. This is displacement versus what? Distance graph. Displacement versus distance graph. Here we may take arbitrary points, مثلا P here. Here let's say this is A. This is B, for example. Let's take this is C. This is D. Now we want to find the phase difference, guys, between these 2 points, right? Phase difference between these points, right? Between these points. We may consider okay, guys, look to this. Now we might be asked to find the phase difference between P and Q. Phase difference between P, sorry. Let's start with P and what? Q. Pay attention, guys. Now to find the phase difference between P and Q, this is displacement distance. I will use this formula. X over lambda times what? 360. هذا هو phase difference. This is what the phase difference. And if I want to find the phase difference, I have to find the shift. I have to find what? The shift. Look to the shift here. P is at 20. Its position at 20. Right? We Q its position at 60. Right? So difference البوزيشن shift x is 60 minus 20 over الwavelength here is 80, right? Wavelength is 80 times 360 degree. This becomes 40 over 80 times 360 degree, which is give me 180 degree. So guys, the phase difference between P and Q is 180, which means that they are oscillating anti-phase. They are oscillating what? Anti-phase.
استاذ من وين جبنا ال 80؟
الويف لينث 1 complete cycle. هي ويف كامله لهون، شايفها؟ Is it clear؟
يس
طيب.
يس.
طب أستاذ
Yes.
لما نعوض إنه إحنا هذا الجراف مبين وين ال 90 وين ال 180 وهذا كله، لما نعوض الأرقام هيك
بصير.
بعدين ناخذ دغري من
بصير.
لما نطلع عليه بدون حسابات.
بس المين بروبلم
ممكن؟
المين بروبلم مثلا إذا قال لك احسب لي بين A و B،
أوكي.
شايف؟ هلا between A and B الاكزاكت بوزيشن ما راح تقدر تحدده بالثيتا بالانجل. انا I know your point. فانا هلا باجي بطلع الشفت هون، خلينا نشوف قد ايه الشفت. هذا 1 2 3 4 صح؟ 8 هاي راح تكون، والبي راح تكون 40 صح؟ over 80 هذا اللي هو الويف لينث times what؟ 360 degree. Okay guys, if I want to find the phase difference between B and C let's say، أو راح يكون لا بلاش ناخذ B and C، ناخذ A and C. A and C same thing، بس نشوف قديش C عندنا هون. C 2 4 6 8 70 72 74. فالفيز ديفرنس هون راح يكون 74 minus كان 4 صح؟ over ايش 80 اللي هو الويف لينث times 360 degree times 360 degree. In this way guys we can find the path difference between any 2 points.
أستاذ minus 8 مش minus 4.
minus
74
sorry
minus 8.
sorry. Yes, divided by 80 times 360. يعني هاي جايز
أستاذ مو فاهم كيف بطلع إكس أنت؟
هلا فهمك فيها. هاي بتطلع عندنا 144 degree الفيز ديفرنس، وهون الفيز ديفرنس راح تكون 74 minus 8 66 divided by 80 times 360 بيطلع 297 degree. اوكي مرة تانية طلع كيف بطلع الاكس الشفت. هلا احنا we need الشفت عمر between let's say A، قد ايه البوزيشن تاع A؟ هاي خليني I will use هذا A right، وهذا what؟ C. اوكي هذا هو الشفت.
اوكي
اوكي
خلاص
جايز
فهمت.
هذا هو الشفت. divide هذا الشفت in position على wavelength times 360 or times 2 pi you will get the phase difference between these 2 points. Okay, you will find the phase difference between any 2 points on the wave. طبعا here I can find between A and D, I can find between A and C, B and Q, no matter the points we have to use this formula. But we have to focus on one thing here guys. What is the type of a graph? Is it displacement distance or displacement time graph? Okay, displacement what? Time graph. هلا we may have a question like this انه sorry Okay. Now, the question that I did before was about the phase difference between 2 points, right? Phase difference between what? 2 points. Now, guys, we might be asked to draw another wave at certain phase shift. At certain what? Phase shift. يعني you might be asked to draw مثلا another wave after a quarter cycle, or after half a period, or after 360 degree in a phase difference of 360 or something like this. Okay, so I have to show you how what we will be asked to find. Okay, here we are given the wave. On figure 6.1, draw another wave after quarter cycle. طلعوا after ايش؟ Quarter cycle. Okay, after what? Quarter cycle. هلا, we are not asked to find the phase difference between 2 points. We are asked to draw another wave after quarter cycle. Another wave after what? Quarter cycle. هلا, to do this, guys, here we are given the shift in time. Guys, this is the shift in time, right? Because يعني here t small shift in time هو 1/4 مين؟ البيريد. 1/4 البيريد. هلا, الشيفت in time is the same as shift in position in the simple waveform. So a shift in time had a 1/4 cycle, معناته الشيفت in position راح يكون 1/4 lambda. Okay, guys, same shift in time will be the same as in the wavelength. Again, guys, here we are asked to draw another wave بس هاي الويف shifted او الشيفت تاعها كم؟ 1/4 period. تمام, يعني I want to show او let's say like this wave. هلا مثلا اخذت اول سناب شوت عند تايم معين, بعد كوارتر سايكل اخذت another ايش سناب شوت. فهمتوا علي؟ يعني كان انا عم بعمل 2 سناب شوتس على الويف هاي اللي قدامي. one at certain time, والثاني راح تكون بعد quarter period, بالضبط بعد quarter period. ف راح اعمل like this, راح اخذ quarter shift. هلا الشيفت بالتايم راح يكون exactly the same as shift in position. يعني الشيفت اللي هو t هون راح يكون نفس الاكس كشيفت, لانه التي حكينا هذا الشيفت in time, والاكس هي الشيفت in position. شو يعني هذا الاشي؟ This means, guys, انه every point is shifted by the same magnitude. يعني الاكس هون هو 1/4 لامدا, 1/4 اللامدا هون 80. هيها اتفقنا راح تكون هي 80. فهون قد ايه راح يطلع عندي 20 سنتيمتر. شو يعني هون؟ every point on this wave is shifted by 20. يعني انا راح اعمل shift لكل point by 20. طلعوا كيف راح اعمل هذا الشيفت؟ I will select major points. ايش هم الميجر points؟ هاي crest 0 هون, trough 0, crest 0. I will shift them only. I will shift them. I will shift. طلعوا معي هون. Guys, pay attention please. It's an important one. Shift this point 20. هايها هاي البوينت shifted 20 وهاي البوينت shifted 20 برضو وهاي البوينت shifted 20 وهاي shifted horizontally 20 this point is shifted horizontally 20 this point is shifted horizontally 20. Clear? I shift the major points. Then draw a wave using these points. Okay. طبعا I can't complete it in this way. Guys, here, this is the wave, the red one. This is the wave if I make a snapshot after quarter period. يعني راح تكون الويف بهذا البوزيشن. راح تكون الويف وين؟ بهذا ايش؟ البوزيشن. to draw this I have to find the shift in position. هيها. هذا اللي طلعته أنا shift in position. This shift in position 20, what does this mean? I will shift every point to 20 طبعا to the right. Then I will draw the wave. Any question, guys?
Okay, guys. Here we have, let's say, let's consider this wave. We have particles that are oscillating, like these particles, as what we see here. When these particles are oscillating, we can say that there are particles that oscillate in phase, like these. First set هدول أول first set أو first two particles they are oscillate in phase بنحكي عنهم تمام. واللي تحت they are oscillate anti-phase أي شايفة or totally opposite يعني when one of them is moving up the other is moving down. Third one بنسميه out of phase. okay بنقول هدول in phase يعني مثلا هون if I consider this okay if I use a snapping tool okay if you look to this and this these two particles are oscillating in phase right oscillating in phase ليش لأنه يعني if this particle is moving down this particle is moving down if this particle is moving up the other particle is moving up as well. okay this particle with this particle are anti-phase because as this particle moving up this particle to find the phase difference here, look, find the phase difference in the following cases. I have to take two corresponding or two equivalent points to find the phase difference. And here I took a crest with a crest, right? It's around 100.
شايف البوينتر.
عم بحط يعني هون شايف. Wait a second. Okay. Here I considered this crest with this crest, right? So they are equivalent. The phase difference between them is 100, right? I considered approximately this trough with this what trough around also ish 100 and so on. So the phase difference here is 100. Sometimes here similarly I took two equivalent points 270, 180. If we are given the phase difference, or phase, sorry, we can easily find the phase difference. If we are given what? The phase, like this, we can easily find what the phase, can easily find the phase difference. What does this mean? هلا انا اطلع على سناب شوت اللي اخذتها هون. هاي التايم، شايف التايم؟ مفترض انه هذا هو التايم. After quarter cycle I have to take another snapshot, but when؟ لما يكون هذا البوينتر بهذا، صح؟ هذا الكوارتر سايكل. Is that clear? Okay.
No.
طيب. If I try to do this, ابدا ما زبطش. يعني شيء قريب. You got my point. يعني احنا we want to make, or we want to take another snapshot when the يعني after quarter cycle, or when the time becomes ايش؟ It's ايش؟ quarter cycle. هلا we have to compare the phase here with the phase here. Okay, we have to compare them, or we have to draw another wave. هلا to do this I can do something. Now let's talk about the wavefronts. Wavefronts هم التوب view of the waves, right? Top view of the waves. And it seems that I'm observing the movement of the waves from the top. From where? From the top. Okay. But if I look to the waves from the top, from this position, I will see planes like this. Right? It's similar to someone drops a stone in a water pond. I will observe what? Like this, right? Circular waves. Okay, هدول نسمي wave fronts. Wave fronts. Ray, just a definition, was something virtual line, but it shows the direction of travel, which always drawn perpendicular to the wave fronts. Like this. Here, these are wave fronts. Right? The line that is drawn here هذا بنسميه ايش؟ ray. The ray must be perpendicular to the wave front. And so on. Here, this is the ray. Now we have something is called ripple tank. I think you took that below level. Ripple tank, guys, it's used to demonstrate the wave fronts, or the behavior of the waves also. Okay, let me show you this video.
You'll see it produces circular waves. They simply this device is known as a ripple tank, we can show it to show a wide variety of wave phenomena, but the particular one I want to show here is interference between two sources. The ripple tank consists of a tank, shallow tank of water, a light here which projects through the water, and so you can actually see the ripples on the surface below. And here we have a vibrator with two arms. At the moment I've got one of them out of the water. When I turn this on, you'll see it produces circular waves. They simply spread out from that point there, more or less constant speed. There's a little bit of dispersion, but very little, and so you see the waves.
Okay. Here, as what you see here, Mai, we have generator here. Okay, this is what generator, a wave generator أو dipper. هذا اسمه dipper. هذا الدبر disturb الووتر سيرفيس، فبيعطيني زي ويفز هون. طبعا هذا shallow water tank. Transparent water tank, because I want to show or I want to observe the shadow here. Okay, here these are the shadow of the waves. This is called ripple tank. طبعا the light is projected from top here. في عنا light source. Okay, so we observe the shadow of the waves below below the water tank. We will use a mobile phone camera or any type of camera. No need to be a mobile phone, but any camera to freeze or to take a photo for the waves, or we may use something called strobe scope. The strobe scope is used to freeze the waves. Okay, is used to freeze the waves, so I can make any investigation related to the waves. Like this. طبعا here we may use plane dipper to produce plane waves. I may use rod dipper or spherical dipper to produce circular waves.
Number 14. It's the intensity of light, which is an important point, guys, which we will be commonly asked about these things. About this thing, sorry. The intensity of light. What is meant by intensity of light? It's the power transferred per unit area. يعني I can define it like this. Power transferred to a certain area okay, guys. Also, this intensity is proportional to the amplitude squared. This is an important point. And inversely proportional to the distance squared also. So using these relationships, I can write the following. I think you are familiar with that now. I2 over I1 equals A2 over A1 squared. Guys, A here, A, the symbol that is used here, not area, it's amplitude. Or I2 over I1 equals D2, sorry, not D2, D1 over D2 squared. Because the intensity is inversely proportional مع مين؟ مع distance from the source. Okay, guys. When I or when we are given that إنه intensity of light or intensity of sound whatever is 13 watts per meter squared, this means that the energy transferred for a surface of 1 meter squared by the waves is 13 joules per 1 second. يعني each 1 meter squared of this surface will be ايش or let's say will gain energy equivalent to 13 joules for each second. This is what is meant by intensity. يعني intensity includes energy transferred per unit area per unit time. يعني بنشوف قد ايه الانرجي لكل area per second او power per area. Here this is a past paper questions multiple choice. A light meter measures intensity of light falling on it. Theory suggests that this varies at the inverse square of the distance. طبعا أكيد. Which graph result supports of this theory. طبعا احنا ال inverse proportional here guys must not touch ايش لا ال x axis ولا ال y axis. This is why they are, because the curves must not touch the axes. It's not a linear. So if I draw I versus 1 over d squared, I got a straight line. This is inverse proportional, guys. Even that the graph is straight because it's 1 over d squared. Let's talk about coherence, guys. 3 minutes, but only I will explain the coherence. Coherence, guys, waves that they have constant phase difference. يعني look to these waves, guys. The red wave, guys, is shifted away from the blue one. If you look here, guys, this is the shift. Since they have, or along the wave, the shift is the same no matter the value of the shift. Listen to this, guys. No matter the value of the shift. يعني if the shift is 90 degree, if the shift is 180, if the shift is 360, 45 degree, whatever, but it should be constant. يعني the shift should be constant no matter its value. These types of waves are called coherent, guys. These types of waves are called coherent. يعني, and I can say that the blue wave and red wave are coherent since the phase shift between them is the same. طلع على هاي الويف. عندنا هون two waves. Let's compare their crests and troughs. هذا البوزيشن تاع الكريست التراف هون. Guys, here until this point the waves are coherent لأنه الشفت ما في شفت. هون طلع الكريست وطلع الكريست هون هاي الشفت. تراف مع تراف. هذا الشفت تاعنا طلع شو صار بالشفت هون؟ هون increases, shift increases. طلعوا هون. Compare this to this. Then the wave becomes incoherent or not coherent because the shift between this trough and this trough is different than the shift between this crest and this crest. فهذا بنسميه احنا ايش non coherent waves. Regularly, guys, the laser give us a coherent waves, but the light incoherent. البالبس هاي كلها incoherent. الليزر coherent. طلع هون عندنا random phase shift. هون عندنا constant phase shift. Another way, this is incoherent, this is coherent. Random phase shift on constant phase shift. Okay. Okay. Can you go to page 46?
Okay.
Okay. Here we are given a wave. We are asked to calculate period, and we are asked to calculate what? Frequency. طبعا هون you have to, this is distance versus displacement versus distance. Displacement versus distance. And we are asked to find what? The period. In order to do this, I can't find the frequency of the waves unless I know the wavelength and the speed of sound. The speed of sound 330 meters per second. Okay. To find the period, we have to find the wavelength أول شيء الwavelength from the graph هي one cycle أو I may consider crest to crest أو trough to trough. هاي one cycle أو one wave. Okay معي؟ فسو الwavelength كم؟ 0.6. الفريكونسي يكون velocity over wavelength. In this way, I can find what? The frequency. If I found the frequency, I can find what? The period by taking the reciprocal of the frequency. Is that clear?
Yeah.
Okay. The important one, this part, B. On a copy of diagram, draw a wave of the same frequency but 4 times the intensity. Because we know that the intensity is related to the amplitude, we have to use the relation between intensity and amplitude. First of all, here the amplitude is what? 1, 2, 3, 4, 5, 5. Okay? 0.5. So the amplitude here A1, let's say, is 0.5 centimeters. I will use this relation. I2 over I1 equals A2 over A1 squared. This is the relation between intensity and amplitude. Okay? This is the relation between intensity and amplitude. The intensity here, we are given that the new intensity 4 times this intensity, right? We are given that the new intensity is 4 times the intensity or the original intensity. So substitute 4I1 over I1 equals A2. We have to find it over A1, which is 0.5 squared. Yep. Clear? I1 cancel by I1. We need what? To find A2 in order to draw this. Take square root for both sides. So 2 equals A2 over 0.5. So A2 equals what? 1.
And the second amplitude is 1. What I have to do, the same frequency, and the wave or the wavelength will stay the same, but the amplitude is increased. And instead of here, it will be at 1. 0, the same thing. Omd equal -1, 1, 0, and so on. I may draw it. Okay. This wave has an intensity that is equivalent to 4 times the intensity of the previous waves. Here we have a question about an oscilloscope. We are given wave on oscilloscope, and we are asked to find the frequency. It's easy. We have a formula. I gave it to you before. In order to find frequency, I have to find the period. In order to find the period, I have to measure peak to peak distance. Then I have to multiply it by here. Consider this high peak to peak distance. Peak to peak, right? Addition on peak to peak distance 1, 2, 3. With time base, is it? Look, it's given here. This is the time base. 0.5 milliseconds. Milliseconds. So this becomes 1.5 times 10 to the power minus 3 seconds. Frequency equals 1 over period, which is 1 over 1.5 times 10 to the power minus 3. So I can find what? The frequency. Calculate the wavelength. Since I have the frequency, I can find the wavelength because I know the speed of sound. Sorry, I did not find the frequency yet. Right, I have to divide wavelength over frequency.